Good morning, afternoon, and evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're talking about solving quadratic equations by using the square root method. Now, I want you guys to understand that we've done a lot of the legwork here already on solving quadratics. Real quick, before we really get to the lesson, I want to bring you back in time a little bit. Do you guys remember when we were asked to solve something like this? X squared, let's say, plus, let's say, 5x plus 6, okay, equals 0. Do you guys remember seeing that? Yeah, right? Well, remember that we talked about this. We know what kind of a polynomial this is. This is a degree of 2, and we call polynomials with a degree of 2 quadratics. A binomial is when you have two terms, guys. But when you have a power of 2, it's called a quadratic. So what we have to do to solve here is we factor. What times what is 6? And when added together is 5. That's going to be 2 and 3. Very good. And then we're going to use the zero product property. And we set x plus 2 and x plus 3 equal to 0. So x will equal -2 and -3. If you guys remember, these are the solutions. They're also called the zeros. They're sometimes called the roots of a quadratic function. And a quadratic function is a U-shaped graph. So if you guys remember when we were learning this, I said, guys, what we're finding is not just two random numbers. What's happening here is that this parabola, this quadratic function, happens to go through the -2 and the -3 points on the x-axis. You guys remember that? So we've already started solving for quadratics, okay? We've already started. Today we're going to start learning, and in this chapter, we're going to start learning many different forms, okay? Different ways to do this. And first of all, please remember that as far as the linear function, or the quadratic function goes, y equals ax squared plus bx plus c, or f of x equals ax squared plus bx plus c is the same thing. F of x or y is your independent, is your dependent variable, and x is independent. There are 5 ways that we can solve, y'all. Square root method, completing the square, using quadratic formula, factoring, which we've already done, and graphing. So that's what we're going to learn. That's the goal for chapter 10, how to find the rest of these methods. And the first method we're going to talk about is the easiest, but it's also one of the most useful. Okay, it's very popular, very common, and it is the square root method. And in order to solve quadratic functions using the square root method, first of all, the function must be in the following form, guys. It has to be in y equals ax squared plus c. All right. Notice that there is no bx because the value of b here is 0. So if you have a 0 times an x, you're going to get a 0. When the function is in the above form, again, I repeat, y equals ax squared plus c. So you have your x squared term, maybe a coefficient in front of it of 1 or something else, and you have a constant. You do not have a bx term. If you have a bx term, you cannot use the square root method unless you complete the square or do other things to manipulate it, okay? But if you're going to use the square root method, it must be in this format. All right, so when the function is in the above form, simply set y equal to 0, set it to 0, and solve for x. Your solutions are x-intercepts. They're also known as the real zeros or the roots of the function, which I just gave you an example of 2 minutes ago. So now, start about some square root properties. Luckily, we know these properties. Luckily, we just finished a test on square roots and on radicals in general. If I have an equation, x squared equals the square root of a, okay, where a is greater than 0, of course, has exactly 2 solutions. This will be x will equal plus or minus the square root of that value. What am I talking about? If I told you guys evaluate square root of 4, well, that's 2. If I told you guys evaluate the negative square root of 4, that'd be -2. If I tell you guys evaluate the plus or minus square root of 4, it'd be plus or minus 2. Whenever I tell you to evaluate, you evaluate depending on the sign of the coefficient. However, when I am solving an equation, my brothers, I have to have the plus or minus. When I have something like this, x squared equals 4, okay, and I square root it, x in this case can be plus or minus 2. Because whenever you're using a square root to solve, you must include the plus or minus. You will not get a reminder. You must get the plus or minus. Why, Modal? Well, because 2 times 2 could be 4. So 2 squared does equal 4. But negative 2 times negative 2 also equals 4. So you have a plus or minus here. You guys with me so far? Okay. Has to happen. Same exact thing with complex solutions. If I have x squared equals square root of a, where a is less than 0, it's a negative, has exactly 2 solutions. Plus or minus I times the square root of the absolute value of what's inside of that radical. For example, if I have x, sorry about that, let's see if it does it again, x squared, let's say, equals negative 8, okay? I'm going to square root both sides. X is going to equal plus or minus 2i times the square root of 2. We already know that once you take out the I, you've taken the negative away from the radicand, and that's what you'll be left with. But you will be left with a plus or minus. So again, guys, I don't want to be a broken record, but I want you to understand. Whenever you use a square root to solve an equation, whether the solutions are real or complex, they must be plus or minus. Does that make sense? All right, let's kick it out then. Nice and easy. All right, so we have x squared minus 64 equals y. Yes, you can absolutely do this because I don't have a bx. Yes, sir. Yes, there's 2 ways to skin this cat, okay? You could, this is why having tools in the toolbox is very important. You could go, wait a second, Mortal. This is a difference of squares, man. This is x plus 8, x minus 8 equals 0. So x equals plus or minus 8. Can't you do that, Mortal? Yes, you can. But today I'm teaching you a new skill. Today I'm teaching you, okay, let's set that equal to 0, and let's just solve for x. So add 64 to both sides. But let's be honest. Let's say you forget about difference of squares. Let's say you don't recognize it. Square root that bad boy. X is going to be plus or minus 8. That's the square root method. But it only works if there's no bx term. If you have an x squared and an x term, no square root method, we got to go somewhere else. Here, I've got 3x squared minus 27. Again, if I factor out a 3, I'm going to have a difference of squares, but let's learn the new skill. Make y 0, 3x squared minus 27. Add 27 to both sides. 27 equals 3x squared divided by 3. X squared equals, come on, Mortal. That was weak. That was weak what I just did. Come on, Mortal. X squared equals 9. Square root both sides. X equals plus or minus 3. Make sense? Easy, right? Yeah, all right. Good job, guys. All right, here we go. All right, we got an x squared term here. Okay, it's squared. How can I get rid of that power of 2? That exponent of 2? Square both sides? Wrong. Okay, reciprocal, that doesn't make sense. How do I get rid of a power of 2, guys? Square root it, yes. No, it's not radical it. It's not square it. It's not reciprocal it, guys. Learn the vocabulary. In order to cancel out a power of 2, you square root both sides. Sorry, I wasn't ignoring you. What's up, my brother? Yes, sir, please. Both sides. You have to square root both sides. Because, guys, what happens when you square root a power of 2? Cancels out. Guys, didn't we talk about this? Square root of x squared equals x. I know we talked about this. We just had a test on this. Okay, so the power of 2 gets canceled out with the square root. So I have x minus 2 equals square root of 25. Wrong. It is plus or minus 5. We had just discussed that the fact that whenever I square root, I use a square root to solve for a variable, it must be plus or minus. Did we not go over that? Do you guys understand that? Okay, so x minus 2 equals plus or minus 5. So I've just created 2 different equations. Really? Now I have to add 2 to both sides. So x equals, what's positive 5 plus 2? 7. What's negative 5 plus 2? Negative 3, and those are my solutions. And again, what do those solutions mean, Moro? Well, here's negative 3, here's 7. It's a positive, so that means it's going to go up. We'll talk about how I know that later. But these are my solutions, and my parabola is going something like that through the x-axis. You're understanding what the solutions mean, right, guys? Because that's really important. Just as important as finding the solutions. Yes, no, maybe, kind of, sort of. May I move on? Any questions, please? Okay. Here. Okay. Just like anything, guys, I always want to try to get things alone, okay? We've talked about solving radical equations already, and we learned already we want to get radicals and or powers alone. So the first thing I'm going to do is I'm going to, excuse me. I'm going to subtract 20 to both sides. Now, I have y minus 5 squared equals a negative 16. Okay, what do I do? Okay, we do not square both sides. Because when you square a power of 2, guys, you're now raising it to the 4th power. And you can square root it. However, think about it, guys. Can any value ever be squared and give you a negative? No. Yeah, so this is no real solutions. The reason why I'm putting no real solutions is wait a second. We know complex solutions. Hello? Come on, Moro. We can do it because we have the skills. Square root it. We got y minus 5 equals plus or minus 4i. Add the 5 to both sides. Y equals 5 plus or minus 4i. You have 2 solutions there, guys. They're not real. They're complex. But bless you. But you have 5 plus 4i, and you have 5 minus 4i. So yes, we can work with complex solutions. I forgot that we've already learned that. Does that make sense, gentlemen? Okay. A couple more. We got x squared, y equals x squared plus 81. I want to solve. So 0 equals x squared plus 81. So that means 81. So that means x squared equals negative 81. Square root both sides. X equals plus or minus 9i. Guys, don't forget the plus or minus. It will really mess you up. Okay. And then last but not least, I'm going to go ahead and subtract 14 to both sides. So I've got x squared equals negative 12. Square root both sides to cancel out the power of 2. X equals plus or minus 2i square root of 3. Beautiful. Now, I didn't hear a lot of people giving me that answer. Hopefully you remember, guys, how to break this down. 12 is 4 times 3. All right? You got a negative inside, so that's an I. So you have plus or minus 2i square root of 3. Okay? Does that make sense, guys? That's the square root method. Now, when we're solving equations in quadratic form, but not necessarily in a beautiful, pretty form, there's a way that we can factor that and solve it, okay? Sometimes you will have to solve equations that are in quadratic form, but not quadratic at all. They're in a quadratic form, but they're not. But they're not quadratic. Okay, they're not quadratic. It's very easy though to solve these types of equations as long as you can evaluate and substitute. So bear with me, guys. All of us know how to factor. If we don't remember how to factor, I suggest going back to your notes and or lesson videos and relearn it because you're going to need it. I have x to the 4 plus x squared minus 12. Whoa, that is not a quadratic. That has a fourth degree. That is what's called a quartic, according to what you taught us, Mr. Morrill. If you're thinking that, you're absolutely right. But it is in quadratic form because it's a trinomial. And although you have a 4 as a degree, you could reduce that. You could divide that by 2 and get a 2. So this could be in quadratic form. When you have something like this, let's look at what it says to do. Find the correct substitution using the first and second terms, must be in standard form, using the letter U, and rewrite in the form of AU squared plus BU plus C. Okay, that's real nice, and it may be Chinese to most of you, so let me break it down. What's going to happen here, guys, is that whenever you see that it's in quadratic form, you got to put it in standard form first of all, highest degree to lowest degree. This already is. Take the second variable term. I do not care about the coefficient, but this guy right here, that second variable term, that's your U. So U equals x squared. If U equals x squared, guys, and I square U, what's x squared squared? So isn't x to the 4th really U squared? Take a look at what I just said. Think about it. Look at it. I made U x squared. So if I square U, it's like squaring x squared. So isn't this first term really U squared plus U minus 12 equals 0? So that's my first step. Find the U, replace it, and substitute. Now step 2 and 3 and 4 are easy. Well, let's go one at a time. Step 2, solve for U. So just like normal factoring. U, what times what is negative 12, but when added together is positive 1? Bam, good job. So U equals negative 4 and 3. That's step 2. Step 3, solve for the variable in the original equation using the value of U. We know that U equals x squared. So let's plug it in, brothers. U, which is negative 4, equals x squared, and U, which is 3, equals x squared. Yes, sir? Okay, so no worries. So now I want to solve. So solve x equals plus or minus 2i, and square root it plus or minus square root of 3. Those are my solutions. When you have things that are in quadratic form, but they're really not quadratic at all. And of course, we're going to have examples. But before we get to examples, does that make sense, guys? Okay, I'll take that as a yes. I'll keep this up, though, so you could see what's going on. All right, so for example 3 here, we have for A, y squared minus 5 squared minus 3 y squared minus 5 minus 4 equals 0. It's a trinomial. I'm going from a squared to a 1 and then to a constant. I think this is in quadratic form. So let's go ahead and solve this. It's going to be really hard to solve this the way it is. But if I go ahead and say, wait a second, Morrill taught us that the U is the middle variable term, not the coefficient, not the coefficient. So U equals y squared minus 5. That part is my U. You with me so far? Well, if that's my u, don't I have y minus 5 squared? So isn't this term right here my u squared? Minus 3u minus 4 equals 0. Does everyone understand how and why and where I put that u? How I put that u? Everyone sees that, brothers. Okay? So now factor. U, what is negative 4, but when I have to give negative 3, brothers? Negative 4, positive 1, very good. Now you have to do the, come on, Moto, the zero product property. So u equals 4 and negative 1. Now I got to substitute. Remember that u equals y squared minus 5. So u, which is 4, equals y squared minus 5. And u, which is negative 1, equals y squared minus 5. When I add 5 to both sides here, I get 9 equals y squared, square root of that. Y equals plus or minus 3. When I add the 5 over here, I get 4 equals y squared, square root both sides, so y equals plus or minus 2. So my answer to A is y equals plus or minus 3 and plus or minus 2. Does that make sense, guys? All right, guys. Now, let's continue. For B, I got 3x minus 5 square root of x minus 2. Believe it or not, that is in standard form. And the reason that that is in standard form, guys, is because what is the degree of this x? Of this x right here, guys? 1. What is the degree of this x right here? 1/2. So I am going in standard form, which is lowest, greatest to least. So what do you think my u is going to be here? Okay, my u is going to be the square root of x because I already said that you only want to deal with the variable, never the coefficient. The u will never include the coefficient, ever. So now, what happens if I square root of x? Yes, sir? Good. Yeah? Yes, sir. Thank you. Yeah. I have no idea what you said, sir. I'm sorry. Yes, I ignored the 5, just like in this one when I said u equals y squared minus 5, I am ignoring the coefficient. I am ignoring the coefficient. I only deal with the variable part. If it's something with encapsulated in a parentheses, that whole thing is the u. In this particular case, what's being multiplied to the coefficient is the square root of x. Thank you so much. So like my boy just said, if I take the square root of x and I square it, I get x. So guess what? This is 3u squared minus 5u minus 2 equals 0. Now we're going to do the cubic method. We know how to do this already. 3u. My new c is negative 6. What times what is negative 6? When we're not together, it's negative 5. Sir, thank you very much. Negative 6, positive 1. Imaginary factor. So I've got u minus 2 and 3u plus 1 equals 0. So u equals 2 and negative 1/3. Let me stop right there. Talk to me as far as how to get the u. It's half the battle for this question. Getting the u is half the battle for this question. Questions, comments, concerns? How did I get the negative 6? Thank you very much, my brother. Well, I got to multiply the cubic method. You multiply A times C to get the new C. Thank you, son. Okay. Now, I know that u is 2 and u is negative 1/3. So plug it in. u, which is 2, equals the square root of x, and u, which is negative 1/3, equals the square root of x. How do I get rid of a square root? Okay, so I square both sides, x equals 4. Mona, why isn't it plus or minus? Because I did not use a square root to solve. I squared to solve. And then here I square both sides as well. So x equals 1/9. So my solution is x equals 4 and 1/9. Does that make sense, gentlemen? For sure? Okay. Last two. Okay. What about this bad boy? We got 4x to the negative 2 plus 13x to the negative 1 minus 12. What can the u be here? No, there is no x. What can the u be here? Okay, guys, no worries. It was just part of my job to teach it. Guys, it belongs to the middle variable, not the coefficient, just the middle variable. So u equals x to the negative 1. I don't know why you guys kept saying x over and over and over again. There is no x here. There's an x to the negative 2 and an x to the negative 1. And u is x to the negative 1. So this is 4u squared. Because what's x to the negative 1, guys? Squared. X to the negative 2. So that's 4u squared. Plus 13u minus 12 equals 0. Cubic method, 4u, new c, negative 48. What times what is negative 48? We'll add together a positive 13, positive 16, and negative 3. Imaginary factor of 4. So I have u plus 4 times 4u minus 3. So u equals negative 4 and 3/4. Now I have to plug it in. Have to. So u, which is negative 4, equals x to the negative 1. And u, which is 3/4, equals x to the negative 1. Okay. I can't work with x to the negative 1, so what does x to the negative 1 become? So negative 4 becomes 1 over x. So x equals negative 4. And 3/4 equals 1 over x. So x equals 4/3. And those are my two solutions. We don't have oodles and oodles of time, but we got time. Talk to me. We only have one more left to practice this skill. Questions, comments, concerns, problems, issues, dilemmas. Sir, thank you. Of course I can, my brother. Thank you for asking. Okay. So once we have the u, okay, which is negative 4 and 3/4, now, my man, I'm going to plug it back in here to find my x. Right? So u, which in this case there's two u's, negative, when u is negative 4, that equals x to the negative 1. And when u is 3/4, that also equals x to the negative 1. So this is negative 4 equals 1 over x. Well, cross multiply, right? So you're going to get negative 4x equals 1 divided by negative 4. So x equals negative 1/4. Here, this is 3/4 equals 1 over x. Cross multiply. 3x equals 4 divided by 3. X equals 4/3. Does that help, my man? Do you understand? Promise. Everyone else? Yes, no, maybe? Okay. Last but not least, let's go ahead and do this so that we can see everything and go from there. Okay, we drop this guy. Let me go ahead and take this guy and put it over here. And that way, everyone has everything that they need. Okay, so here, my brothers, this is in quadratic form. It is in standard form already because 2/3 is greater than 1/3. Okay, the exponent of the leading coefficient here 2/3 is double the middle one, so that's another little hint that lets you know it's quadratic. What's my u? 8 to the 1/3. Very good, my brothers. So this is u squared plus 3u minus 28 equals 0. Factor it. What times what is negative 28, but when added together is positive 3? Positive, that's okay. And minus 4, positive 7, negative 4. Great job, my brother. Equals 0. So u equals negative 7 and 4. Now that I know what u is, plug it in. So u, which is negative 7, equals a to the 1/3. And u, which is 4, equals a to the 1/3. How do I get rid of a 1/3 exponent? Which in other words, the cube root. You cube it. Very good. No, you cube it. You don't cube root it, you cube it. Good job, brother. So this is negative 343 equals a. And cube this guy, and 64 also equals a. And bada bing, bada boom, guys. You know how to use the square root property, and you know how to substitute and solve polynomials that are in quadratic form. Thank you so very much. Hope you had a great day, learned a lot. God bless you, and I'll talk to you later. Bye-bye.